transdermal. Have you guys done your sites for intramuscular injections yet?
No.
Okay. You guys will do those on fundamentals and in lab. When we look at our maximum volumes for injection, if we're doing intramuscular injections for an adult, it should be no more than 3 mLs. An adult arm should be 1 ml. So this is where you guys get your flu shots. This is where we give pneumonia shots. When we're looking at a child 6 to 12 years of age, we're looking at 2 ml. A child 0 to 5, we're looking at 1 ml. And an infant, we're looking at 0.5 milliliter. Your subcutaneous injection should not be more than 1 milliliter. I think this is a question on your homework. It asked like how many. So this upcoming homework, also for homework 8, has stuff where you guys have to write stuff in. I have to go in and hand grade those. Just like I had to go in and hand grade question number 20 on the last homework. So after we know how much medication we're giving, we need to select a syringe. So you calculate your dose and then you look for the most appropriate syringe size. They have the 3 ml syringe here, which is you can see the half. The half lines are pretty easy to see. It's pretty easy to do a whole ml. But if you're doing something, a smaller amount, you're going to want to be maybe a little more accurate. So then we have a 1 ml tuberculin syringe, which is, as you see, the lines on it are more accurate. We can go up to the 100th on that. Because each of the tiny lines on there is one 100th. And each of the larger lines is 1/10. So it's easier to get a more accurate reading when you're doing a small amount. So we have rules for selecting our syringes. First rule is we look at the amount of the injection to administer. If it's 1 milliliter or more, we use the standard 3 ml syringe. If your injection is between 0.5 to 1 ml and calculates evenly to the tenths, you can use either the 3 or the 1. And then rule number 3 says that if the amount to inject is less than 1 ml and rule 2 does not apply, which means it does not calculate evenly to the tenths, then you use the 1 ml tuberculin syringe. It goes to the hundredths. So if we're looking to administer 0.6 mLs, which syringe would you use?
The tuberculin. Yeah.
So it rounds evenly to it's less than a milliliter. It's 0.5 to 1 milliliter. And does it round evenly to the tenths? Then 10th spot. So since it is less than 1 milliliter and greater than 0.5 milliliters and calculates evenly to the tenth, we could use either a 3 or a 1 ml syringe. We could use either. When we're looking at rounding our amount to administer, we round the volume to the greater than 1 ml to the nearest tenth. If our volume is less than 1 ml, we round to the nearest hundredth. So greater than 1 ml, we round to tenths. Less than 1 ml, we round to hundredths. So calculate the amount to be administered. If we have 1.66 mLs, what are we rounding that to? One 1.7. The volume is greater than 1 milliliter, so we round to the nearest tenth. So 6 is in tenth spot, and to the right of that's another 6, we round it up. So we are going to give 1.7 mLs of the medication. Which syringe would we use? A 3 ml syringe. If we did our math and we came up with 0.532 mLs, how much would we drop into the syringe? 0.53. Because the volume is less than 1 milliliter, so we round to the nearest hundredth. So it's 0.53 mLs, and which syringe would we use? The 1 ml syringe, because we're going to hundredths. We're going to do a couple dosage calculations because they're in here. So doing dosage calculations for injections is just like doing dosage calculations for any of our other medications that we give. We convert if necessary, we calculate and check. So if our ordered dose is 7.5 milligrams and on hand we have 5 milligrams. So what's our ordered dose?
7.5.
7.5 milligrams. What do we have on hand? 5 milligrams. How does it come?
1 milliliter.
In 1 milliliter. So we cross out the milligrams, and what do we end up with? 1.5. So we're giving 1.5 milliliters. What would be the proper syringe to use for 1.5 milliliters? A 3 milliliter syringe. So this has the step 1. It has the orders, the on-hand quantity, and the desired amount.
Are there any grains on the test?
No.
There's an awful lot of grains on here.
Yeah, I know. No. There might be 1 grain question. I have to look at it, and I will give you the conversion for grain.
Okay.
Yeah. And then they set up the problem here. And then when it says to check your work, does this make sense? The desired dose is 1.5 times the available amount. So the answer makes sense. We would use a standard 3 ml syringe since that's the amount to administer is greater than 1 ml. So when we look at medication expressed in a ratio or a percentage, medication labeled as percentage or ratios must be converted before calculating the amount to administer. So percent means per 100. It means per 100 means grams per 100 milliliters. Ratio means grams per ml. Except for heparin, when the ratio means the number of units contained in 1 ml. So we have some practice questions. It says ordered is 0.5 milligrams of epinephrine stat. On hand, we have epinephrine 1 to 1,000 solution. So when we look at this, it's a ratio. So it means grams per milliliter. So when we look at this, we have our ordered dose is 0.5 milligrams. On hand, we have 1 to 1,000, which means 1 gram to 1,000 milliliters. So before we can do this, we need to convert the order to match the units on hand. So we have milligrams and we have grams on hand, so we have to convert milligrams to grams. So to do that, we divide by 1,000. So we end up with 0.004 grams is now our desired dose. And then when we do the division here, we have 0.004 grams over 1 gram. And then we multiply times 1,000. You don't like that?
Is this gonna be on our final?
Right.
I think the one on your final is actually a heparin question.
So what?
Heparin,
What is that?
gram comes from, because when you look at a ratio, it means 1 gram per ml. That's where the gram came from. You want to dip the person sitting next to you? So we have magnesium sulfate at 300 milligrams IM order. And on hand, we have magnesium sulfate 10% solution.
No, it's 0.4.
Yeah.
I mean, it's the same.
Miss Lockhart.
Yes.
Okay, so what if we put 4?
What do you put for? What?
0.4. For that
For the
previous
last
answer.
Have you put 4 for this answer? Huh?
For that answer.
This one?
Yeah.
Yeah, this one. It would be wrong. If you can't get 4 milliliters, you would kill somebody.
So why is that on the calculator? It's not coming up right.
Why you gotta make that face?
Oh, it was 0.004. That's right. Just a decimal. Right. Yeah.
Where did this come from? This came from chapter 14 in your book.
On my schedule when I miss
Because when you have a ratio, it means grams per ml. And since it was written that you have 1 to 1,000, it's 1 gram to 1,000 milliliters for the medication. So you convert what you ordered to grams, and then you set up the problem. When you look at percentages, it means grams per 100 ml. So if it means grams per 100 ml, for this one, we have 10%. So what does that mean if percent means grams per 100 ml? What does that mean? 10 to 100, 10 grams to 100 ml. Because this is 10% solution. So this is 10 grams to 100 ml.
Where you get the 100 from?
Because percent means grams per 100 mLs.
So it'll be 10 over 100.
Hmm?
So
So now you have to convert your order to grams. So how do you make 300 milligrams grams?
Divide out.
So we divide this by 1,000 and we end up with what?
0.3.
So 0.3 grams is our ordered,
Over 10
and we have on hand 10 grams
times 100.
times 1,000, by 100 milliliters.
That's amazing.
What do we end up with?
3.
Woo! I don't know why I just wrote in the spreadsheet. It's not gonna erase.
Uh-oh.
It looks like someone spent a lot of time getting the board clean.
Ms. Lockhart, so any percent will be.
Any percent is per 100, so whatever the number in front of it is how many grams, and it's in 100 milliliters. When you have a ratio,
It's over 1,000.
it's 1,000. So if it was 2 to 1,000, it would be 2 grams per 1,000 milliliters. If this was a 3, it would be 3 grams. So your ratio is always, the first number is your grams and this is your milliliter. When you look at percentage, this is your grams and it's always with 100 milliliters. I think there's some of these questions on your homework. The one on your final, I believe, is a Hepburn question. We're going to do that. Huh?
This one.
Hmm?
Okay.
Oh, I'm glad you. I'm so happy to know that. Oh.
Just skip.
No, look at it. No, it's slowly down.
So if we have heparin, so heparin, we have an order for 5,000 units of heparin sub-Q every 8 hours. On hand, we have 1 to 10,000 of heparin. Calculate the amount to administer. You guys remember the rule for heparin?
No. You said it was 1.
So when we look at heparin, heparin has its own little rules. Let's get another mark besides that red one, because that red one's not erasing.
See, now that's confusing. So is that 1 ml?
1 ml contains 10,000 units.
Oh.
What? Because heparin's always in units. So when we do this, we end up with our ordered units of 5,000 over what we have on hand, which is 10,000, times 1 ml.
So when you cancel out.
Yep, your units cancel out, you're gonna end up with milliliters. 0.5 milliliters is what you're gonna get with the vial.
Yeah, that one.
Yeah, that
So
was
for the
easy.
test,
That
we
was
have to
easy.
remember 10,000. So it's gonna be that one on the test?
It's gonna be a heparin one. It may not be the exact same numbers, but it's gonna be a heparin one, and you need to know that your first, it's gonna be milliliters to units.
Can we do some more than that? Might be like the one.
Can you do some difficult ones?
Huh?
No difficult one.
What a difficult, you know,
Right, I'm like, whoa.
Right.
Look, Dr. Shanae put that on you once today. He was like, that's how I can tell.
The one you don't see him today.
What he said? He said that?
That's all I can say. That's all I can tell you.
Okay, so this is the
That's
same
not good.
conversion that we just did.
That's what.
No, you're gonna see Hefford on your final. You might see a ratio and percent on your homework that's due on Friday, but you will not see them on your final.
What is that?
No ratios on the final.
Good. There you go.
You like everything.
When we're looking at reconstituting these medications, this is like reconstituting any of the medications that we talked about. We're gonna read the vial or the package and see what we need to add to it. So calculate the amount to administer after reconstitution for an IM injection of 400 milligrams. So you have to read the package to see how you reconstitute this and what the strength is once you reconstitute it. It's IM injection. To prepare IM suspension, add what?
3 milliliters.
3 milliliters of sterile water for injection. Shake gently to disperse and withdraw completely the resulting suspension.
So you just do.
The directions?
No, I said.
Oh, it says IM injection right here.
No.
So we read the IM injection for the suspension there. If we were doing IV, we would do 7.
Okay.
But we're doing IM, so it's only 3. So what's our ordered dose then? Yep. So if you have 400 orders,
You better go.
and now we added 3 milliliters of water to make a 750 milligram solution. So
So
it's
it's 7.
750 on the bottom, because that's what we have on hand, times what?
3.
3 ml. So how much are we giving? 1.6? What syringe would we use?
3.
A 3 ml syringe. There are going to be pictures of syringes, I believe one on your final. You guys have to shade in the syringe and how much you would put in the syringe. Don't make that face at me. My goodness. On the final. Yes. You'll have a picture of a syringe and you'll shade in how much you would like to give that amount. So you're going to calculate a dosage to give. You're going to come up with a number. And then you're going to look at the syringe. I only have a picture of one syringe. So it's not like you're going to pick multiple syringes. You're going to look at that syringe. You're going to color in how you would fill the syringe to give the medication, like how much you would draw. If you actually draw that medication, where it would go to in the syringe. You just kind of shade it in. Mm-hmm. Yep. Nope. I'm going to have a syringe there. You're going to color it from the answer you get.
It'll probably be a decimal.
I guess you guys will see.
But when are we going over that then? 'Cause I'm not sure about all those little lines.
We're going to go over more with that. It will be on the practices you guys get for the final, which I will hand out on Wednesday. Next one.
We got 2 minutes left. Hurry up, 'cause I'm out of
I know it
here.
doesn't.
Our class is only
We're
1
gonna
hour. It
talk about
started
that
at
right now.
Frame is a bunch of Chinese.
Okay.
Yes. Hey, she.
I don't know.
We got 15 minutes, you guys. We're going to talk about safe dosage ranges again. We talked about this last week or the week before. I gave you guys that sheet to take home and help you guys figure stuff out. So the first part of this is we convert the body weight to kilograms if necessary, which means we divide by what? 2.2. We find the desired dose by multiplying that times the weight in kilograms. And then we determine if it is safe. And we're going to practice. So our label states, our order is rigidity. 30 milligrams every 8 hours for a child weighing 52 pounds. Label states contains 50 milligrams per 2 ml. Recommended pediatric dose is 2 to 4 milligrams per kilogram per day. What's the first thing we need to do? Convert our weight. So we take 52 and do what to it?
Divide by 2.2.
Which equals what?
Kilograms.
So our child weighs 23.6 kilograms.
Convert kilograms.
Now what do we have to do?
Convert
Multiply this weight by what?
to 1,000.
Try again.
It's 3.
No.
1,000.
We're looking at the dosage range.
You multiply by 2 and multiply by 4.
So we're going to multiply by 2 because it's our low range and by 4 because it's our high range.
Oh, really?
You said 47.2? And what's another one? So now our safe dosage range. So we can give between 47.2 and 94.4 because you took these two ranges and you multiplied by the weight in kilograms. So now we look at how much is ordered. How much is ordered? 30 milligrams. So if we're giving 30 milligrams, how many times a day are we giving it? Every 8 hours, which is 3 times a day. So what's 30 times 3? 90 milligrams per day is what we're giving. Is this dose safe? Yes. Because it falls between here, does not go over 94.4. So we have a safe dose. Once we know we have a safe dose, we have to decide how much to give. So we have 30 milligrams as our ordered dose. What do we have on hand? 50 milligrams times 2 ml. How much would we give in each dose?
1.2.
And then you look to see if this makes sense.
That's it.
What doesn't?
No.
Okay, well, we look to see if what we're gonna give makes sense. So we look at we're only giving 30 milligrams and it comes 50 milligrams in every 2 ml. So obviously, since we're giving less than 50, we're not gonna give more than 2 ml, it's gonna be less than 2 ml. So 1.2 makes sense because you're giving less than 2 milliliters for every dose. If our ordered dose was 60 milligrams every 8 hours and we came up with 1.2, would that make any sense?
No.
No, because every 50 milligrams is in 2 ml. So if we were giving 60, that wouldn't make any sense. So then the next few slides do the same thing that we just did on the board. Okay, next one. Let me erase all my lovely stuff I
So
wrote
like
here.
on this sample test, you gave a study guide, and it says, it's a dosage ordered as safe and then proved mathematically, you want to stop at that point then,
When
right?
you're proving mathematically, you're gonna be doing this.
Okay,
This is your mathematical proof.
okay.
What's ordered and how many times a day you're giving it.
Oh, shit.
That's your mathematical proof.
So it would end right there. It
Yeah.
wouldn't be the stuff you just used.
Oh, because I didn't give you guys the answers, that's why.
50 milligrams
We're gonna talk about it on Wednesday if I didn't give you guys answers. Okay, you guys, so here we have another dosage. We have amoxicillin, 750 milligrams, every 8 hours for a child weighing 32 pounds. Label states, children should receive 20 to 40 milligrams per kilogram per day in divided doses every 8 hours. So what's the first thing we do? We have to get the weight in kilograms, so we take 32 and divide it by 2.2, which gives us what? 14.5 kilograms. Now that we have the child's weight, what do we multiply that by? 20 to 40, because we're looking at milligrams per kilogram per day. So we take 14.5 and multiply it by 20. It gives us what? 200.8? 290.8.
Just got 290.
You guys are killing me.
290, it's 290.
Telling y'all.
It's like our desire.
That is not safe.
What's not safe?
This
So we got 290 milligrams per day. Then it's 40. I would ask you guys, but obviously I'm giving the wrong answer.
565.
This part of the way.
I got 580.
580 milligrams per day. What is our ordered dose now?
Is
750.
750.
How many times a day?
3 times.
Green.
I can't.
What's 750 times 3?
No.
2250.
You are.
Would we give this to a child?
No.
No, because our one initial dose is what? Our initial dose is 200 milligrams over per day that they should get. Yes.
I have a question going back to the IM injection. If your bottle is 15 mLs and you reconstitute with 2.1, then you add 15 to 2.1? How do you do that?
I'm not understanding your question. Try that again.
Okay, a 15 ml bottle
Okay, of dry medication.
powder.
Okay.
Right. And then reconstitution is 2.1.
Mhm.
So do you add the 2.1 to the 15?
No, because your powder is not milliliters. It should be like some kind of grams or something. It should not be in milliliters.
It's 1 gram per 15 milliliters.
Are you reading a homework? What are you reading from?
Oh, no.
Okay. What number on the homework?
It's 3.
Okay, give me 1 minute to finish this problem, then we'll look at that homework. I brought the homework up here. So we would not give this to our child because obviously 1 dose is more than what the daily dose should be. Okay? Anyone? You stop right there.
Yeah, once you find out if you have to.
Once you know it's not safe, you stop. You know it's safe when you look at the recommended dosages.
As long as it's below.
As long as it doesn't go over your high dose. So, question number 3. If you read the item, huh? No, I have. It says that for the, are you looking for an IM? You're looking for an IM administration? It says for IM reconstitute with 1.2 of lidocaine,
2.1.
2.1 of lidocaine or sterile water for injection, and then each milliliter contains 350 equivalent. So you don't look at what you look at what, when you reconstitute it, what it's